Gasoline. It's the fuel that powers most of our cars, trucks and motorcycles. But what exactly is it? Gasoline is a liquid made from crude oil, a fossil fuel found deep underground. It's a mixture of different chemicals called hydrocarbons. These hydrocarbons give gasoline its energy. One of gasoline's most important characteristics is its flammability. It ignites easily, which is what makes it work in engines. When gasoline mixes with air and encounters a spark, it burns rapidly, releasing energy. This energy powers the pistons in your car's engine, making the car move. Another important characteristic is its volatility. Volatility means how easily a liquid evaporates. Gasoline evaporates quickly, which helps it mix with air in the engine. This mixture is what allows for efficient combustion. Because gasoline evaporates so easily, it's important to store it properly in sealed containers to prevent dangerous fumes from escaping. Have you ever wondered how we get gasoline from the ground to our cars? It's a fascinating journey. It all starts with crude oil, a thick black liquid found deep underground. Crude oil is a mixture of different hydrocarbons, and gasoline is just one of the many products we get from it. The first step is to extract the crude oil from the earth. This is done by drilling wells deep into underground reservoirs where oil is trapped. Once the oil is brought to the surface, it's transported to a refinery, often by pipelines or tankers. At the refinery, the magic happens. Crude oil is processed and separated into different products, including gasoline, diesel fuel, kerosene and asphalt. This process is called fractional distillation. It works because different hydrocarbons have different boiling points. The crude oil is heated, and as the temperature rises, different hydrocarbons vaporize and are collected separately. Gasoline and the internal combustion engine grew up together. In the late 19th century, inventors were experimenting with new ways to power vehicles. Early automobiles used steam or electricity, but these had limitations. Gasoline, with its high energy density and portability, emerged as a promising alternative. The first gasoline-powered automobiles were rudimentary, but they quickly evolved. The development of the carburetor, which helped mix gasoline with air for efficient combustion, was a major breakthrough. As cars became more popular, so did gasoline. The demand for gasoline led to the growth of the oil industry. New oil fields were discovered and refineries were built to process the crude oil into gasoline. The automobile revolution was in full swing, and gasoline was its fuel. Section 4. Octane, the power behind the pump. You've probably seen different octane ratings at the gas station, like 87, 89 and 93. What does octane mean and why is it important? Octane rating refers to a fuel's ability to resist knocking or pinging during combustion. Knocking occurs when the fuel-air mixture in the engine ignites unevenly, causing a knocking sound. A higher octane rating means the fuel is more resistant to knocking. High-performance engines often require higher octane fuel because they have higher compression ratios. Using a lower octane fuel than recommended can lead to engine damage over time. Octane rating is influenced by the chemical composition of gasoline. Refineries can adjust the octane rating by adding certain chemicals called octane boosters to the gasoline. So, the next time you fill up your tank, remember that the octane rating you choose can affect your engine's performance and longevity. Section 5. Gasoline's impact, the price of progress. While gasoline has revolutionized transportation, it's important to acknowledge its environmental and health impacts. Burning gasoline releases pollutants into the atmosphere, including carbon dioxide, a greenhouse gas that contributes to climate change. Air pollution from gasoline-powered vehicles can cause respiratory problems and other health issues, especially in urban areas with heavy traffic. The extraction and transportation of crude oil also pose environmental risks, such as oil spills that can damage ecosystems. Recognizing these impacts, there's a global push to transition to cleaner and more sustainable transportation fuels and technologies. Section 6. Fueling the future, alternatives and innovations. As we look to the future, the way we fuel our vehicles is changing. While gasoline remains the dominant transportation fuel, alternatives are emerging. Electric vehicles, powered by batteries, are becoming increasingly popular. EVs produce zero tailpipe emissions, making them a cleaner alternative to gasoline-powered cars. Other alternatives include biofuels, such as ethanol and biodiesel, which are derived from renewable sources like plants. Hydrogen fuel cells, which convert hydrogen gas into electricity, are another promising technology. The transition to alternative fuels and technologies is a gradual process, but it's essential for reducing our reliance on fossil fuels and mitigating climate change. The future of transportation is about finding cleaner, more sustainable ways to keep the world moving.